Hello viewers. So in this video, we'll be looking at trigonometric function of real numbers. Now in the previous section, we talked about trigonometric function of angles. Now we want to see the relationship between these two. How can we move from trigonometry of angles to trigonometry of real numbers? So if you have, let's say we have a unit circle. So when I say unit circle, we're talking about a cycle of radius 1. So let's assume you have a radius of 1. So we consider the unit cycle. Now the radius is 1. So it means that if the radius is 1, this point is going to be 1, 0. And this is going to be minus 1 and 0. So if the radius is 1, it means we have the radius is equals to 1. So let's assume you pick a P, you pick a point here. This point is given as X and Y, right? So it's a point on the unit circle. Now, since it's a point on the unit circle, what does that mean? It means that if we have this to be a right angle triangle, this is going to be our X and this is going to be our Y. And what you can see from here is that what? We have X squared plus Y squared is equals to 1 because your radius is 1, right? Now, another thing we can see is that what? This point, let's say we have this, we have an arc length from here to here. This length is, we call it S, right? And remember before we said here is going to be theta. So if this is an arc length, we say that what? S is equals to what? Is equals to r theta. So where S is the length from where? The arc length from this point to the point P, right? But here in this case, you can see that what? The radius is 1. So since the radius is 1, we're just going to have what we call S is equals to theta. So it means that what? But remember, theta here is in radian. You see theta is in radian, right? So it means the theta, it means the S and the theta, they have the same units in this case, right? So it means the angle, now theta is in radian, but S now is in what? It's also going to be in radian. So they have the same units. So we can replace, so instead of using theta here, instead of using theta, we can now change this theta to S, right? Because S is the same thing as what? Theta, when the radius is what? Is 1. So now this S, let's say this S, we call it T, right? So we can say T is the same thing as what? Theta. So let's call this S to be the same thing as T. So it's just a real number because you remember S is the length of the arc. So the arc length from this point to this point is just T. So it means that instead of having theta here, we can just put it as what? As T. And you can see that we can still have all the what's, we can still have all our trigonometric functions. So you can see that sine t, if you use this t now, sine t is going to be y, which is y over what? R. But r is equals to 1. So we have sine t is equals to what? Y. Also, we can have cosine t, which is going to be, cosine t now is x over r, but it's going to be x over 1. So you see how we moved from where? We moved from radian just to any real number, simply by using what we discussed before, which is the arc length. Arc length is r theta, but here theta is equals to 1. So S is the same thing as theta. So it means that we can change from angle to what? To just any real number, right? Which is the S. So here we just replace S with what? With T. So you can use any variable you like. All right, so that is why we have all of this. Sine t is going to be y, cos t is still x, tan t is going to be y over x. As you can see from here, you can find tan t. Tan t is just what? Y over what? Over x. All right. So this is what we call circular, you can call it circular function, because everything we use this circle to generate it, the circle of radius 1. Okay. So now that we have established the relationship between the trigonometry of angles and that of a real number, we can talk about the domain. So if you look at sine and cosine, the domain is all real numbers. So now instead of just restricting ourselves to finding, for example, we are used to finding sine 60, let's say sine 30 and all of that, and let's say sine 45. All of these are angles, right? So now we can find something like sine 2. Yes, sine 2 is possible. We can find something like sine 0.5. We can find something like sine what? 5. You see that all these numbers now are what? They are the t's, they are the real numbers, not necessarily angles. So here, sine and cosine, they have the domain to be the whole real number. So you can take any number from where? From minus infinity to where? To infinity, and you can find the sine, you can find the what? The cosine, okay? Then for tan and sec, the domain is all the real numbers minus what? The zeros of the denominator, which are pi over 2 plus what? Plus n pi. And so let me explain this a little. For cotan, okay, let me explain for tan. For tan, for example, if you say tan t, remember tan t is going to be what? It's going to be sine t over what? Cosine t. So if you want to find the domain, what will be the domain? The domain will be the whole R minus what? The zeros of what? Cosine t. Because this is like a rational function. So you have to remove the what? The zeros of cosine t from R. And what is the zero of cosine t? In other words, we say this is going to be R minus, okay, let's find the zeros of cosine t. Cosine t equals to what? 0. What does this mean? We don't want cosine t to be 0. Or in other words here, let me write it here. We can say R minus what? Cosine t not equals to what? 0. Or you can say t such that cosine of t is not 0. Right? But what do we mean by cosine of t is not 0? If you don't want cosine of t to be 0, you need to remove all the zeros of cosine t. And already we discussed this before. If you have these, let's say you have these quadrantals, right? So let's go this way. Remember, this point is going to be 1, 0, and this point is minus 1. So this is x is equals to 0, y is equals to 1. This is minus 1, 0, and this is 0 and minus 1. So you see, where do we have cosine t to be 0? You have to remove it. For example, here, if you are here, what does that mean? 1, 0 starts for what? Cosine 0 and what? Sine 0, right? And here also you have cosine 360 and sine 360, right? So where do we have the first component to be 0? You see, you have the first component to be 0 where, let's look at this point. This one. This is 0, so it means that cosine is 0 here. Where do you have another 0? You have another 0 here. So it means cosine is also what? Is also 0. So you can see that what it simply means is that what? When you say that what? Cosine t okay. So when we say cosine t is not equals to 0, it means that t should not be what? should not be pi over 2, right? Because if t is pi over 2, this is cosine. Remember, the first component is cosine. So this is like cosine, what? Cosine 90, which is cosine pi over 2, and sine pi over 2, right? Okay. And also, if you come down here, you see, this is what? This is cosine 270. So also, it cannot be 3 pi over 2, right? All right. But if we go again, we can still go. Once we go after this, we come back again after like another revolution, we will meet another 0, right? So in other words, we can just generalize it that t cannot be what? Cannot be pi over 2 plus any what? N pi. And this pi must be what? Any integer. So for example, now, if you take n to be 1, what do you get? You get 3 pi over 2. But we know that t cannot be 3 pi over 2 because cosine 3 pi over 2 is 0. If you take n to be 2, you will see you get 5 pi over 2. Cosine 5 pi over 2 is still 0. You can even take n to be minus 1. So that is why we say n has to be integer. For example, if you take n to be minus 1, what would you get? You get pi over 2 minus pi, so which would be minus pi over 2. But we know that cosine minus pi over 2 is the same thing as cosine pi over 2, which is still 0, right? So here, what we have is that the domain of tan t is going to be what? So the domain of tan t is going to be the whole real number minus what? All of this. T cannot be this. T cannot be pi over 2 plus any integer multiple of pi, where n is inside z. Okay? All right. Now, this is for tan t, and it's going to be the same for what? It's going to be the same for sec t. Why? Because sec is also the reciprocal of what? It's also the reciprocal of cosine. So sec t is 1 over cos t. So it means the domain is also going to be the same thing as this. So the domain of sec t is also going to be the same as this. All right. Now let's talk briefly about which one now? The domain of what? The domain of cotan. Yes, the domain of cotan. So what is cotan? As you can see here, cotan and cosec, they have the same domain, which is going to be all real number other than what? N pi. All real numbers other than n pi. And why is it so? It's simply because of what? Because the denominator is going to be cosine, is going to be sine, right? Let me explain that briefly here. So let me explain that here. You see, if you have, I'm talking about what now? We're talking about cotan. Because we have cotan, remember cotan t is going to be what? It's going to be cosine t over what? Over sine t, right? So if you are looking for the domain, so the domain is going to be r minus what? The zeros of what? Sine t. So the zeros of sine t, in other words, you're saying that r minus what? Any t such that sine t is not equals to 0. So what do we mean by sine t is not equals to 0? We can still use what we did earlier, the quadrantal. If you look at this one, again, the same way, this is 1, 0, this is minus This is 0, 1. And this is minus 1, 0. And this is what? This is 0 minus 1, right? So you see that where do we have sine t to be 0? Where can sine be 0? Sine can be 0 when theta is what? Remember, remember sine is the second one. So you see here and also here. So sine can be 0 when your theta is, or when your t, in this case, we're not using theta anymore. So let's use t. When t is either 0 or what? Or 180. And also when it is 360, right? Because you can see it will come back there. So what simply means here is that the t cannot be 0. So the t cannot be 0. And also t cannot be what? Pi, which is 180. T cannot be 2 pi, which is 360. Because by the time you go around, you're already back here. This is 180. This here is, here you have two things here. It means you have cosine of, not cosine, but sine of 0 and sine of what? Of 360. Yeah, so you can see that this is just for one cycle, right? By the time you go around 360, you will see that you will get 0 how many times? You will get 0 at pi and also at 0 and at 2 pi. So if you keep on going round, you'll keep on getting 0 at those so at any pi distance. So you can see from here to here, from this point 1, 0, by the time you get to minus 1, 0, you get how many zeros? You get 2 zeros. By the time you go again, you will meet another 0 here. So in general, we can just write this, that t should not be what? N pi, where n is any what? Integer, because you can decide to go clockwise also. You can go back this direction. So if you go this way, you will still meet zeros. So in that case, n can be negative. So we have t is not equals to n pi. So that is the domain, as you can see. And it holds for what? For both cosine and what? And for both cosine and cosec, because both of them have the same domain, because you need to remove the zeros of sine from the real numbers. All right, so let's just take a few questions. Another thing here is the range. This one we will just discuss. For sine and cosine, the range is from -1 to 1. For tan and cotan, the range is from -infinity to infinity. And for sec and cosec, we have the range from -infinity to -1, union 1 to infinity. We'll talk much about this next, maybe in section 6.4, right? And 6.3. So example 1 here is simply asking, which of the following statement is possible or impossible? Now, sine t, this is saying that what? Remember, t is coming from the domain. So can sine t be equals to 2? Now, this is not possible because of the range of what? Because of the range of sine. Because what it means is this. Remember, we talked about range and domain before. What is range? It means if you have this range, let's say you have a function. Your function is sine function. And this is t, right? So the t is coming from the domain, and the output will be in the range. But the domain here, what is the domain? The domain here is going to be from minus r, or you say minus infinity to infinity. But the range here is going to be just from -1 to 1. You can see. So it means t can be anything. T is not the problem, but the output is the problem, because the output cannot be more than 1 and it cannot be less than -1. But here you can see this is the output. The output is 2. So this is impossible, because you cannot get this one as the output for sine, because no matter what you take t and you put in here, the output is just going to be it's going to be a number between -1 and 1. Okay. Similarly, this also, is it possible? Yes, it's possible, because this is -0.9, which is inside the range, the interval -1 to 1. So this is possible because of cosine, the range of cosine. Now, sec is 0. Can sec be 0.5? Now, what is the range for sec? This is the range for sec. The range of sec is -infinity to -1. So this is what we have. For sec, we have -infinity to -1. So this is -1, close. And then we have 1 to where? To infinity. So you can see, but 0.5 is somewhere here, which is impossible. So it means that this is going to be impossible. What of cosec? Cosec t is equals to 3. Yes, this is possible, because 3 is going to be somewhere here. And you can see 3 is going to be here. So this is possible. And for tan t, this is also possible, because the range of tan is what? Tan and cotan, the range is the whole of what? Of R. All right. So this is just by using the range of these trigonometric functions.